Hey Course 3, in today's lesson we're going to review and learn, I think, 3 laws of exponents. Exponents, remember, are a counting number that indicates in the kind of the top right of a number, like right here, how many times that number is being used as a factor. It's probably the best way to define it. An exponent shows the number of times that this base is used as a factor. So x to the n means, n number of times it's going to be used as a factor over here. For example, 9 to the third means 9 as a factor 3 times. That's the best way to say it. Some laws of exponents. X to the fifth times x to the third. You might think x to the 15th, and that's going to be the most common mistake in today's lesson and probably through the future. But when you multiply two bases that are the same, different exponents or the same, what you do with the exponents is you add them. Let's see why. If you look down here, what are we actually doing? X to the fifth looks like this. That's x to the fifth. X 5 times. Then x to the third looks like this. X used as a factor 3 times. That's all being multiplied, right? You multiply x that many times, you do not have 15 x's used as a factor. You have x used only 8 times as a factor. You end up adding the exponents. X to the fifth and x to the third multiplied means x to the 8th with an exponent of 8. Okay, so we just proved that we add exponents when we multiply like bases. How about dividing? What are we really saying we're doing when I do, let's say, 3 to the fifth divided by, same base, 3 to the third? A lot of people are going to say 5 divided by 3, which would not be fun. The good news is the exponent of our final answer is actually much simpler than trying to divide those. What are we really doing? 3 is being used as a factor 5 times. 1, 2, 3, 4, 5. 3 on the bottom is being used as a factor 3 times. 1, 2, 3. Cross out the way we've learned how to reduce with primes or whatever. You've got a 3 here left and a 3 here left. 3 times 3, or 3 used as a factor 2 times, means 3 squared, doesn't it? So what did we do with the exponents when we divided? We found the difference between them. So when you have like bases divided, we subtract the exponents. So 5 and 3 were subtracted to find an answer of 3 to the second. Find the missing exponent. This time we've got x to the third, not times x to the second, but x to the third really raised to the second. I like to show it further up. So we've got x used as a factor 3 times, and we're using that twice. So we're not saying x to the third times x to the second, so it's x to the fifth, and it's certainly not that. It's instead x to the third used as a factor twice. What are we really saying? X to the third times x to the third. How many times is x used as a factor here? 1, 2, 3, 1, 2, 3, 6 times. So if you raise x to another exponent, you actually do multiply the exponents. When you have a number like 2 squared, and you square that whole thing, it's 2 to the 2 times 2, 2 to the 4th. Or if I have 3 squared to the 6th, right? You got 9, but then 9 to the 6th. So what we're doing is multiplying this. Okay, so it would really be the same as 3 to the 12th. All right? Those are the laws of exponents as summarized here at the top of the page. These are really important to practice and get down. x to the a times x to the b is x to the a plus b. We add the exponents. X to the a divided by x to the b is x minus exponents, and x to the a raised to the b, then you multiply the exponents. See how this and this are different? These are different. Add here because of that, and multiply here because of that. Example 4. Write each expression as a power of 10. 10 to the 8th times 10 to the 6th. We've learned instead of multiplying all that out, we're multiplying like bases, so we add the exponents. 8 plus 6 is to the 14. Dividing 10 to the 8th divided by 10 to the 6th, we find the difference in the exponents, 10 squared. Pick one from each section, please. Best of luck.